Hello, ROS developers. This is Ricardo here and doing a re-recording of our last live class that was about Linux for robotics. They had a problem during the emission of this live class, and what happened was that my computer completely collapsed because of I didn't have more battery, and I forgot my adapter, my charger actually on at home, and then I didn't realize that was almost out of battery. So that's what happened. I am sorry for that. I apologize, and that's what the things that kind of errors that happen when you want to do more things than the ones that you should. Okay, so this is just a reminder. So let's not try to do too many things. Okay, so let's go for the class today, and this is the ROS that I'm going to open, as I already shared with you, with all of you who attended there at the class. So I'm going to open it and go step by step on the live class. So I'm going to repeat all the steps up to the point that the class was disconnected, and then afterwards I will continue until the end. Okay, so don't worry, let's go. Then I have opened my project, and now while here it's starting this Jupyter notebook, it's as I mentioned, it's about Linux for robotics. And what is the purpose of this video? Well, the purpose is that, as you know, or probably know, ROS, if you are going to program robots with ROS at present, the only real option is to use Linux, because Linux is the operating system that is running on the computer that your robot may have. And then on top of Linux is where you are going to install ROS. So if you want to use ROS, if you want to program robots with ROS, then you have to learn how to use Linux, at least some basic stuff. Okay, and here in this live class we are going to go into that basic stuff and make you learn the basics so you can handle. And I decided to do this class because I'm doing classes of ROS at the university, and I get course after course, group of students after a group of students, and then I see that most of them, they have never used Linux before. And because of that, then I have to start always by teaching something about Linux. So I decided, oh, why not to create this live class so we can go back to this live class as a reference in the future. And then, as I mentioned, Linux is the operating system. That's the software that runs on your computer. I'm assuming that you have a robot that has a computer attached to it. It's a PC computer. And then it has all the elements, all the devices, cameras, sensors, wheels are connected to that computer for control in some way or another. Okay, more complicated ways or less complicated ways. So that computer needs to have an operating system, and it's going to be Linux if you want to work with ROS at present. Then inside Linux you have a different, let's say, flavors. So the different ways of creating a Linux, and I'm not going to go into the description why is that, but that's the situation. And then the most common flavor, or the most common version of Linux that we use with ROS is called Ubuntu. Okay, Ubuntu, it's the name of a flavor of Linux. Actually, we call a distribution. So, whoops. Yeah, a distribution. Whoop, here. So that's Ubuntu is a distribution, is a type of distribution of Linux. And that's the one that you are going to use if you are going to use ROS. And in this case, we are using Ubuntu 16. That's the number of the version of Ubuntu, and ROS Kinetic. You can find more information about installing Ubuntu here in this link. Then let's go. I want to thank to Christian Chavez for creating this notebook, and he is one of the interns of the Construct, and he's doing a great job here. And he created this notebook under my supervision. So thank you very much, Christian. You are doing very good. And now let's go for what are we going to learn here. So here we are going to learn basic terminal commands in Linux. So you are going to learn also what is a terminal and what is a directory and how it works, what are the system variables, and finally we are going to run a process to make a robot move. And which robot are we going to use in this class is the Talos robot from Pal Robotics. Talos is an amazing human-sized humanoid robot. It's the latest humanoid robot from the company Pal Robotics. And we have here the simulation, even with the walking controllers, that we are going to launch in a minute. Okay, so if you are following this and you got a copy of this ROS yet, the Linux for Robotics, if you got that copy, then please start to follow my steps. So you have to follow what I'm doing here and reproduce the same, so you will get the same results as I have. Then let's go. Let's launch the simulation of Talos. So how do we do? This simulation is included inside this project, and the only thing that you need to do is to launch it. For that, we go to Simulations, then from My Workspace, and then here on this area, we are going to select the Talos Gazebo version 2.launch. Select that and then press launch. So by doing this, you are going to get here the simulation running, okay, in a few seconds. Okay, let's keep moving down. So those are the instructions, as you can see on the notebook. Also, in case that you miss this video for whatever the reason, you can follow directly on the notebook. And then the first thing that we are going to check is what is a directory. Okay, so this is a very basic concept that you need to master. And directory, it's a location, it's like a box in your computer where you can put files. Okay, so the files, you know what are the files? You already know from other operating systems like Windows. The files is where you have your documents or programs or images. Those are files. But then if you want to organize this, you need to have directories. And in directories, you can create a hierarchy of different directories. So that means one directory inside another directory inside another directory. So that's what is shown here in this image. It's a hierarchy of directories. So we have here the simulation workspace directory, and inside it, it has all those directories. Then there is one that is called SRC, and inside this directory there is another one called Talos description, and inside this one there are all those them. And also finally, whoops, sorry for that, yes, so finally we have the files. So you can put files or directories inside other directories. Okay, so how do we move into this structure? How do we move? Well, for that we use some commands. Yes, I know that in other operating systems you just have a graphical tool where you can move between the directories. But if you are going to work with ROS and Linux, then you need to use commands. What does it mean, commands? I mean that you have to type. You have to type in order to provide orders to the software, to the robot, to the programs, and to the system itself. And then where do you type this? Where? So you type your commands in what we call it's a terminal or a shell, also known. So a terminal or a shell, it's a tool that allows you to send commands to the operating system to do things like moving on the directories, create new directories, delete them, execute programs, etc. So you can do all that. Then let's open a shell here. So if you have remember that we are using here the ROS Development Studio, but if you are not using the ROS Development Studio, you are using your own local computer, this also applies. It's exactly the same. So you only need to go to the icon in your computer that is a terminal, or actually you can look for terminal in your computer, in your Linux. Here you will find it in Tools, and then Shell. Okay, Shell is another name for the terminal. Okay, then once you have opened this terminal or shell, you will get something like that. Okay, and here you can see the blinking cursor there. It's waiting for our command. So now you can type. Right? There is type. And then press enter. The system is going to understand the command, but of course it's not a command because I just invented. Then what it's before this blinking space here, it's called the prompt. The prompt indicates several information about your system, as you are going to see in a minute. Okay, so here let's start with our first command. The first command is going to be the cd. Cd means change to directory and then a name of the directory you want to change. So in this case, let me see the example that we have prepared here. It's called Catkin workspace. Catkin _ws. So if I type cd and then the name of the directory, Catkin _ws, then I will move inside that folder, that directory. And you can see that my prompt has changed, indicating now that I am inside the Catkin workspace directory. But I can even move further. So for example, I can move into, again, you follow with me, okay? You repeat these commands at home. Then it is cd, and then I'm going to type src/move Talos. Okay, so now what happened, as you can see, this has also changed, and you can see that the prompt has appended this and this. What does it mean? It means that I have moved from my home folder that I was here. This was my home folder, my home directory. I have moved inside into the Catkin workspace. Then inside the Catkin workspace, I move inside the source, and then inside the source, I have moved inside Talos. So you can concatenate many directories one after another by putting a slash, as far as if this directory is inside the previous one, of course. So that's how we move into the different directories up. If we want to move out of this directory, we will type like this, cd and then 2 dots. Now I have moved out of the move Talos, and then I am on the source directory, as you can see. And then if I do cd again, double dot, then I am out of the source. And if I do again the same command, I am now at my home directory. Okay, well, as you can see, here we have the Talos simulation that has already started, so you should see something like that at home also if you have started. Okay, we are going to make it move in a few minutes. Stay with me. Okay, so let's continue with the next command in Linux that is very basic. It's called the ls. The ls is a directory, is a command that is used to list all the files and directories that are contained in the current directory that you are. So now I am at my home folder. Then I can do an ls and see what is included in this directory. And I can see that there are other directories here, AI, dataset, notebook, and also some files. In this Linux configuration, we can see other directories with ls that are in blue. So if you see those elements in blue, that means that there are other directories. And in white, here we see the files. Then, as you can see here, there is one directory that is called Catkin workspace. So we can go inside. Let's go inside Catkin workspace, and then do an ls here. Oh, okay, so now it has changed. What's the content of this? It's just those 3 directories. And then I can go again inside the src and then do another ls to see what is here. Oh, here we have the directory move Talos, like we have seen it before, and also another file. And now let's go inside the move Talos. Now I am here as I was at this moment. Here is the same. And as you can see, the move Talos is a directory that is inside the source, that is inside the Catkin workspace, that is inside my home directory. Okay, what is inside here, the Talos? These things, some files and some directories. Okay, so far so good. Now we can provide parameters to all the commands that we launch. For example, to ls we can provide the parameter -a. This is an example. ls has many parameters. This is an example. If we do an ls -a, what happens here? Then it shows this list of hidden files that we oh, okay, so we don't have here the hidden file. Let me see, it's not here again, so I deleted the other day, and then yes, so it should have a hidden file here. So let me do one thing. Let me move back again into my home folder, and then you can see here ls-a, all the files that I have. Remember, if I do in this directory an ls, I only obtain this, but if I do an ls-a, I obtain this big long file, this long file. Okay, so what are those files that were not appearing there? Well, as you can see, all the ones that doesn't appear, they do start with a dot at the beginning of the name. A dot means that this file is a hidden file. So it's a file that is not shown when you use an ls. Why would you like to have that? Well, because they usually are related to configuration things that you don't want to bother your view when you are actually working with the files, but not with the configuration situations of your system. That is why they are hidden, so they don't bother us. But with ls-a, you can see those hidden files. Now, we have another command, very basic, that is rm, and is used to remove files. So we can delete files on the system. Then how do we use that? Is rm and then the name of the file. Let's do one thing here. Let's delete this red file that is here. It's catkin workspace.zip. So let's type it. Dot, remember that has to start with dot. Catkin _ workspace.zip. And then if we do that, then we should have removed that one that is in red. And let's have a look now if it exists already. So let's ls-a, then we see that this file is gone. Now it's not there. Okay, so yeah, now you know how to delete files. Then another interesting command is MKDR. MKDR it's a command to create a a directory. Is to create new directories. So if you issue this command, then you provide a name for the new directory, and then it's going to be created. Okay, let's go to the move Talos. I don't remember if move Talos. Let's go again to move Talos, catkin workspace, src, move Talos. Remember that we can move in one single command if we specify the correct what we call a path. Okay, so a path means one directory, and then inside that one move to this one, inside that one move to this one. Okay, if I do an ls here, I already have the source and also the config. Yeah, so let's create another directory here. For example, mkdir data. Data, that means that I have created a directory here that is called data, where I'm going to put some data for training of a neural network, for example. So then if I do now an ls, you can see that the new, let me move up, yeah, the new data directory has been created. It didn't exist before, you see. So that's how you create a new directory in the system. Then how do you delete files? It's rm, yeah? And then how do you delete a directory that is not empty? It's rm -f, -f, yeah, data. -r, sorry. Yeah, -r, sorry. It's because this -r, it's a parameter. You know, it's a parameter as I mentioned before on ls. Then in rm by -r, we are indicating that it has to remove data and everything that is contained inside data. That's it, and whatever it is, even if it's a file or it's a directory. But you cannot do an rm directly on a directory like config, for example. So it's going to provide us with this command. Okay, so what about the parameters of any command? How can I know which parameters any command is accepting? Well, one option is to use the man command. If you do man and then the name of the command that you want to see the parameters, then you will get some answer here that provides you with many descriptions how to use this command, the rm, and then here you have all the options that you can add. Okay, here -f, -i capital, etc., etc. So remember, with man and the name of the command, you can see all the options that you can provide here. Okay, a new concept that we have here, a concept of environment variable. An environment variable, it's a variable where you can put values and that are stored into the Linux system. So any program that is running on the Linux, it's able to see that variable and get the value. So by doing this, you can use a single variable with a single value that applies to any program in your Linux system. And this is very useful in ROS. This is for some environment variables related to ROS. And those environment variables can be seen, so you can see all the environment variables that you have in your system defined by using the export command. So let's issue here the export command. Here you can see that there are many variables. Usually environment variables are in capital. So this is a user variable, and then inside there is the content then afterwards. So you can see many different system variables. And for example, here there are some that are related to ROS. So this is ROS distro that is indicating that the distro that we are using is kinetic, or ROS host name, or one very important here is ROS master URI. If you study ROS, you are going to see that a lot. Or ROS package path, also very, very important. Okay, so those are the variables that are defined. And you can use the export command in order to see which ones are defined. But you can also set the variable, you can also set the variable value by using the export command. So for example, let's have a look at the PS1 variable that is defined here. Let me see, it's around here, PS1, here it is. Okay, so this is the content of the PS1. The PS1, the content of the PS1 is the one that is defining how this is going to look, how the prompt is going to look. Okay, so that's a PS1 variable. That is why we can see this here. So now I have included here another command, an export, and then a new value for the PS1 that you can copy and paste on the terminal. So copy this and come here and paste it. You see, I'm using export and then the name of the variable and then a new value for this equal a new value on the variable. Okay, so that's how you set a new variable, a new value for a variable. Then you can set it, and then what did we do here? Well, we just changed the color from green to blue. That's the only thing that we have done. Okay, but you can see the effect after having changed the name, the value of the PS1. Okay, so that's for variables. Then another very useful command in Linux is called grep. So grep, what it allows you is kind of a filter. So it's a filter by words. That means that whatever you put before the any command that you put before the grep, then it's going to be filtered by the word that you are indicating after the grep. So, okay, I'm not explaining this very well, so let me try it again. So, imagine that we have an export command, okay? What's the output of export? Let me show you. You know already, because already I have explained. So, export, we got all that, okay? All that is the export. Now, we can redirect the output of the export command by using this pipe here. We can redirect into the grep command. Okay, so let me show you here. Export, if I press enter here, now it's going to show me all that stuff, but I'm not going to do it. I'm going to redirect the output, also all this, I'm going to redirect, then I type the pipe, and I'm going to redirect this into the grep command. So grep, that means from the output that this export is redirecting to me, just show me the lines that contain PS1. Okay, so it's going to show us only the PS1. Okay, you see, it's very convenient that, because now if we are looking for this PS1, it's very convenient to look to filter all this trash that is around there until we find the PS1. It's a lot of work. It's a lot simpler to do it like this. And we can do, for example, the same for showing only the variables that are related to ROS. So we say export, and then pipe, redirect into grep, and show me only the ones that contain ROS. Remember that it's in capitals, so you have to type in capitals. And here it is. So we have all the ones, all the variables that contain the word ROS. You can use this grep. This grep is used for many things. You can also do it for not only for export, for LS, for the output of a file, etc., etc. It's quite very useful. We use a lot also. Okay, so having reached this point, let's move the robot. And for that, we are going to use a computer program that we have prepared here, and then we need to do some steps first. So let's do them before we can move the robot. First, let's go to the IDE and see the files that are also included in those directories, but we are going to use an IDE because it's easier to check and to see. So let's go to Tools, and then here select IDE. Okay, so let me put it here in the middle, and this a little bit larger. Then we have to select here the Catkin workspace, and then source here, and then move Talos. Okay. And here in the Talos, we have the Talos movement file. This is a program that we are going to use in a minute for making the Talos robot move. So this is just indicating how you can create this Talos movement by using the IDE, but already created for you here, so no problems. That's the same content that you have there. And then also just remember that if you do any modification to this code, then you have to, one ball here, one white ball will appear there, so you need to save in order to maintain those changes. For example, if I type here a space, now I have done a change, and then the ball is here. You can see is there. Okay, so that is indicating that you have to save. It's not our case because we don't need to, that space is not modified. And now what we are going to do is to compile this code. This is very common in Linux. You create a program. How I created a program, because I have created all this structure of directories, then I have created a new file, here, a C++, and then I have typed all this code here. So it's already done, okay, in order to prevent you to type everything, but is here, so you already have it. But now, what do we do? How do we use this program into the robot? How do we execute? How do you make the robot execute those instructions here? Well, the first thing that we need to do in Linux is to compile the code. We need to compile, okay? And then for that, we need to go to a very specific directory that it's called the Catkin workspace. Only can be compiled, this program in ROS can only be compiled in this directory. So let's go there. You know how to do it because we have to move up 2 directories. Okay, so far so good. We are there, ready to compile. What is this compilation thing about? Well, what this compilation thing is translating from this language here, which is C++. So compiling means that you have to translate this C++ into the machine language that any robot, or actually the computer of the robot, can understand. Okay, so that's compilation. So before we can execute it, we have to make this translation. We have to do this compilation by using the catkin make command. So let's copy this catkin make and issue here. Now it's going to compile, and then, okay, so yeah, it has done it because it was previously compiled. But anyway, the process is the same. You can see here an output in case that you didn't have the code compiled. And if I save this space that I have added, so let me save it. And then I try to recompile now, then it's going to do some extra stuff. Yeah, because it says, oh, there is an strange change there, so let me recompile. So that is what it's doing right now, and it's going to compile. Then, now that you have compiled this, you need to execute that. You need to execute the program. So the program has been created and it is ready to be executed. Okay, where it is executed? Well, it is included in this directory here. And here, directory here, and then here is the name of the file of the program compile that we can execute. So how can we execute this? Well, you can execute a program by providing the complete path to that program. So if I copy this and then paste here, then that is going to execute our program. Okay, so that is the way that we are going to execute. But before that, we need to execute another program because this program of ours, the one that we have compiled, it needs to have some special ROS controllers activated that we don't have yet, because we only launched the simulation, but as you can see, the robot is not activated yet with the working controllers. Okay, so I have included here another command. This is another command that we are going to execute. So this is a ROS command. This is a typical ROS command. Okay, so before I launch my program that is here, let me Control C this. Before I launch this one, I need to activate the controllers in the robot. So you can, if you are here, you can copy the whole command, copy and paste it here. It is very safe. So maybe you will not understand this command because it's quite complex if that's the first time that you are seeing Linux, but just trust me that you need to issue this command like this. And if you start learning about ROS, then you will understand that very well. So now this class is not the purpose. The purpose here is to execute our program. And here we have the program that has been started, and now our robot is put into position. Very good. So it is ready now to execute our program. Okay, so what's the next step is to launch this program, and let me see. Okay, yeah. Okay, so we need, yeah, so we need to execute another program in order to start the working system. Okay, so for that, this is another program that we need to execute. Yes, and I know a lot of preparation programs before we can execute our own program, the one that we have created here. Yes, but this is because this robot is quite complex and we wanted to show you. Then we need to execute this other program here, but the problem is that here we cannot execute anything else because our previous program, the one that we have launched here that made the robot put into the position, this program, it's taking the shell, has taken the shell, the terminal, so I cannot execute anything else because it's still blocked by that program until I close it. But I cannot close it because otherwise the robot will not be able to move then. So I had to keep this open. So how do we do that in Linux? How do we manage this situation? Well, no problem. We launch another shell. We launch another terminal. So let's go and let's do it. Let's go to Tools and then launch a shell. And there, let me do it. Let me put it here. Yeah, many things. So let me just minimize that one because it's already working, so we don't need it anymore. And I'm going to put it there. So that one that I have minimized is here, okay? So we haven't lost. You cannot close. If you close the terminal, then the program will be killed, and then your robot will not work. So you cannot close. I have just minimized. It's running there in the background. It's here, okay? Okay, so then here we have another shell, and we have to launch this second movement one. So this is the one that is activating the controllers, and it's going to start moving the robot actually after a few seconds. Let's see how it moves. Come on, Talos. It takes some time because it's quite a complex program. Even if it has started and stopped, it looks like this, but it is not successfully. Everything has been successfully, so it should start moving. Let me see. Okay, still waiting for you. How is it? Come on, Talos, you can do it. Let me see. Yeah. Okay, so it looks like there is some problem here. Let me see, but everything is correct. Everything looks correct, yes. And on the other, let me see on the other terminal if there is any problem here. Oh, okay. Biped walking DCM controller is not set. Okay, so didn't see that. So let me check if I can see. Wait. Let me see. Could it be that this is a problem here? So let me see. And also maybe here in the simulation we have any problem here. This is the log of the simulations. All support under hook. So that doesn't look. Wait, there was something in red there. Let me see here. Okay, could not adjust priority. Okay, so I don't know. I have no idea. This is something related to the working system of the robot. Let me see if here we have any other message. No. Okay, so yeah, it should move. So let me try and launch our program and see if what is happening. But that has ended very fast. Yes. So let me launch our program and let me test what is happening. So let me go to here, leap. Here we should have the move Talos, exactly. So there is where we have our program that is being compiled. When you have in green a file that is in green, that means that it's a file that is executable, that you can execute. So how do we execute a file that is green, that is on our directory? Well, we have to write the following. We have to write a dot and then a slash and then the name of the file. Okay, that is how we execute this file. That is our program that we have compiled. And I don't know, I'm just launching it just to see if it provides any problem or... Okay, so it's moving backwards. So actually I don't know what happened here. So I don't know what actually happened because this is I don't know actually what is the problem with this command, but don't worry. So that's not the point now. The point is to understand how do we execute a program that we have created or that somebody has created for us. So you go to the directory where it is located and then you type this dot slash and then the name of the program. That is how you execute. As you can see, the program has been executed and makes the robot move backwards. And that's it. Let me see here. It says about some extra problems as about the variable error cannot be found. So I don't understand why it's indicating this problem here, but anyway, so we have everything already set. So the Talos is moving backwards as it's shown here on this image. And basically that's it. I mean, we have seen all the very basics of Linux here with this example. What we have seen, let me recap a little bit. Let me recap. Is first, we have seen how to move between directories by using CD. Then we have also learned how to watch the content of a directory by using ls command. Also, we have seen how to remove files and directories by using the rm command. We have learned also how to create a new directory by using the MKDR command. And also we learned about the environment variables. What is that and what they are used for and how to change their value. Also, we have used the very useful command grep. Let me move the robot here so we can see it. The move command grep that is filtering the outputs based on some text. And then finally, we have compiled a program that makes the robot move backwards. So we have compiled the program and we have executed. And that is all basically. So that's everything that I wanted to show today. And then that's it. In case that you have any problem, let me know on the comments below of this video. Ask me your questions, and also if you want to suggest me the subject for another live class, I will be super happy to have that. And then before we finish, let me tell you about our academy that we have for learning more about ROS. So we have an academy that is called the Robot Ignite Academy that you can check the link here. And it's a super cool academy that it's very, very practice-based. Actually, we have a method that we call the 30-70 method, which consists of using 30% of the time into learning the theory and 70% of the time applying this and testing and doing practice. And how do we do that? Well, we're using the same method that you have seen it here by using the simulations that are already included. And you don't need to have any special installation in your computer because you are going to use a web browser to access all the courses. You can have a look at all the courses that we have with different subjects: ROS for beginners, Python for robotics, ROS 2, how to learn ROS 2, unit testing, self-driving cars, OpenAI, and reinforcement learning, and many other subjects. Have a look there. We have many subjects there. Have a look. It's quite interesting. And that is all for today. And remember, one thing is that in the next 3 weeks we are not going to have live classes. So we are going to stop doing live classes for 3 weeks while we are preparing other stuff, and also because of the summer season. But we'll be back again in August, on the first week of August. So stay tuned with us, and please subscribe to our channel if you like the content, because we are providing new videos every day. So stay tuned by subscribing, clicking on the bell, all that stuff that you already know from other YouTubers. And then that's all from today. And remember to keep pushing your ROS learning. Okay, guys? See you, ROS developers.